While we know a lot about black holes, they still remain as one of the greatest mysteries in the universe. So let's dive in, not literally, to answer all your burning questions about these cosmic enigmas. First, the basics. What exactly is a black hole? A black hole is a region of the universe where gravity is so outrageously strong that nothing, not even light, can escape. Imagine throwing a ball into the air on Earth. The harder it is thrown, the higher it goes. If it was thrown hard enough, it would eventually leave the atmosphere and keep on going. But if we increase the force of gravity, the object would have to be traveling faster and faster before it could break free. If the Earth was compressed to the size of a ball with a radius of 9 millimeters, its gravity would be sufficient to prevent even an object traveling at the speed of light from escaping. In the case of the Sun, which is much larger, this point where escape becomes impossible is just under 3 kilometers. This point is called the Schwarzschild radius. The Schwarzschild radius, or gravitational radius, RS, of an object is the limiting radius at which, if the size of the object equals this value, its gravitational force becomes so strong that the escape velocity of the object reaches the threshold of the speed of light. If even light energy does not travel fast enough to escape, and nothing can travel faster, then no signals of any kind can escape, and the object would be black. We call this mysterious thing a black hole. The only way we know it's there is by feeling its gravitational pull, like anything else with mass. The presence of gravity means that objects can fall into it, and hence it is a hole. So, a black hole is an object so compact that the velocity needed to escape from its surface is greater than the speed of light. Once something enters a black hole by crossing an invisible boundary known as the event horizon, it can never leave. At the center of a black hole sits the singularity, where the extreme gravitational forces reach infinity, crushing everything into an infinitely tiny point. Who named black holes? It wasn't until 1968 that black holes got their name, thanks to physicist John Wheeler, who argued that black holes really do exist in the universe. Other astronomers argued that their strange properties were instead a sign that we were misunderstanding gravity, and that general relativity is incomplete. The debate was settled in 1971, when astronomers confirmed the existence of an intense source of X-ray radiation known as Cygnus X1. The astronomers got a lock on the size and mass of the X-ray source, and whatever it was far smaller and far denser than any other known astronomical object. The only thing that fit the bill was a black hole. The astronomers couldn't see the black hole itself because light does not escape them, but instead were observing the light emitted by matter as it crammed itself below the event horizon, its final deathly screams of light before it plunged itself into the inky blackness of the hole itself. What's inside a black hole? I have to start this answer with a small caveat. We don't know for sure what's beneath the event horizon of a black hole, because we cannot access these regions of the universe. Their interiors really are locked away from our view forever. But we can make a good guess based on our understanding of relativity, which is probably a rather good guess, considering that it's through relativity that we discovered black holes in the first place. There's not much to the interior of a black hole, just all the stuff that has ever fallen through the event horizon, quickly spiraling its way to the center. That center is the singularity, the real heart of the black hole. According to relativity, the singularity is a region of infinite gravity, but we know this is incorrect. Our understanding of relativity is incomplete because we have not yet been able to reconcile relativity with quantum mechanics, which is the physics of the smallest objects in the universe. In other words, The presence of the singularity is a sign that we do not understand gravity at extremely small scales. A better quantum theory of gravity will hopefully solve the riddle. But as for right now, we can only say that we're not sure what happened at the center of a black hole. How are black holes formed? We know of only one surefire method for building black holes, and that's through the death of a massive star. When a star at least 8 times larger than the Sun nears its end, it forms a core of solid iron and nickel. The rest of the star, being rather massive, tries to gravitationally collapse onto this core, but it just bounces off of it. This bounce leads to 2 immediate and catastrophic effects. 1. The star explodes in a spectacular supernova explosion, one of the most powerful events in the universe. 2. The force of the bounce can overwhelm the core, causing it to collapse on its own. This triggers the formation of a black hole with a mass a few times that of the Sun. However, there may be other, more exotic ways to build black holes. In the extremely early universe, less than a second after the Big Bang, random patches of the universe may have achieved absurdly high densities, causing small black holes, each no bigger than a baseball, to simply appear. These primordial black holes would have flooded the universe, and presumably are whizzing around even today. Black holes may have also formed before the appearance of the first stars. A few 100 million years after the Big Bang, gigantic clumps of matter may have directly collapsed into a black hole, skipping the whole star formation part. These black holes would be huge, starting out with a mass of hundreds or thousands of times that of the Sun. Are black holes really black? Confusingly, black holes aren't exactly 100% black, but you can't blame anyone for sticking to the name. After all, gray holes don't exactly evoke the same sense of awe and mystery, and by the time we discovered that black holes aren't completely black, the name had already been around for decades. General relativity says that black holes are totally black, and that nothing escapes. But in 1976, famed astrophysicist Stephen Hawking discovered that strange quantum effects operating at the event horizons can cause black holes to slowly emit radiation. For a typical black hole, it will only emit around 1 photon every year of Hawking radiation. But given enough time, the emission of the radiation will cause the black hole to lose mass and eventually disappear altogether. Crucially, this radiation is thermal, meaning that it's totally random and does not carry any information about what fell into the black hole. This leads to the black hole information paradox, a major unsolved problem in modern physics. Since information cannot be created or destroyed, where does the information go when the black hole evaporates? The first person to successfully answer this question will almost certainly win a Nobel Prize. Has anyone gone into a black hole? No, and it wouldn't be a fun trip. For a small black hole, the extreme gravity would stretch you out well before you reach the event horizon in a process cheekily known as spaghettification. For large black holes, you can pass through the event horizon unharmed, but once you cross that invisible boundary, you'll never escape, and you'll be doomed to reach the singularity, where you'll be crushed into oblivion. What's the closest black hole to Earth? There are likely hundreds of millions of black holes wandering the Milky Way galaxy, but the nearest known one is called Gaia BH1. Discovered in 2022 by the European Space Agency's Gaia mission, hence the name, the black hole sits 1,560 light-years away. There are probably black holes closer to us, but these objects are exceptionally hard to detect. We can only see black holes when they influence their surroundings, like in the case of Cygnus X1, or when they merge together and release gravitational waves. How big are black holes? Most black holes are known as stellar mass, meaning they have a mass of a few to a few dozen times that of the Sun. These absolutely litter every single galaxy, as they are the product of the death of massive stars. But there are bigger ones. Small black holes can grow by merging together and by swallowing new material. These giants, known as supermassive black holes, typically slink their way to the centers of galaxies. The black hole at the center of the Milky Way, known as Sagittarius A star, weighs around 4.5 million solar masses. The record holder, however, is a true beast. It's appropriately called Ton 618, and it weighs a whopping 66 billion solar masses. Thankfully, it sits over 18 billion light years away from Earth, and so we don't ever have to confront that enormity up close and personal.